hear you. Did you ask anything to me?
I didn't ask anything. I just wished you good evening, Neha.
Okay, ma'am. Did I miss anything?
I haven't started anything yet.
Okay, ma'am.
And as you can see on the screen, I have shared a table where you are seeing components and their respective symbols. And this is a quick revision of session 2, which we had last week. So the first concept we have learned is components and their respective symbols. So you know how an electric cell is represented in a circuit, diagrammatic representation, because all the time you may not be able to draw a battery as it is. So we go for a symbol for our convenience. And then group of cells is called a battery. So you can see 3 cells are shown connected, which represents a battery. And then you can see key. If there is no dot between the closed brackets, it means the key is open and the circuit is open. And the fourth one, there is a dot between closed brackets, which means that this is a closed key and hence now current flows in the circuit. It is just like switch on and switch off. When there is no dot, when the representation shows that there is no dot, it means it is switched off and then the current will not flow. If there is a dot, it means current is flowing because the circuit is connected, which means the key is closed. And the next thing you can see 3 wires connected, and that is called joint. Joint is a point where 2 or more wires get connected. And then in the next row you can see wires crossing without joining. A wire is crossing another one and they are not in contact. If they are in contact, we call it as a joint. But without connecting, if it is just crossing another wire, it is this is how we will be representing. And then electric bulb, so far you have seen many times during my explanation how a bulb should be represented in an electric circuit. And then comes a resistor, which offers resistance in the circuit. And then comes variable resistance. If the resistance is varying in the circuit, then that varying resistance should be represented as shown. And then we have 2 devices, ammeter and voltmeter. A stands for ammeter, the device which is used to measure current. And voltmeter is a device which is used to measure voltage or potential difference. What is the symbol of a fuse? The last one. And today you'll be learning about what is this fuse, what is its role in an electric circuit. And then we have also understood what happens when cells are connected in series. Do you remember? What happens when cells are connected in series?
Yes, ma'am. We remember.
What happens if there is a single cell which is offering you 5 volts? Then it produces some current.
Ma'am, the energy will be if there is a 5-volt battery and there is 3 bulbs, means the the current or the charge will be divided into 3.
Yes. If I'm connecting cells in series, all their voltages gets added up. If I'm connecting 5 cells, each of 5 volts, then the total voltage in the circuit becomes 25. So when voltage is more, it produces more current. Yes. So the main thing you have to remember is when cells are connected in series, EMF gets added up.
Ma'am, EMF means electromotive force, right?
Electromotive force, it is just potential difference or voltage. All of them means the same. EMF or voltage or potential difference. This is nothing but the rating you see as 5 volt, 10 volt on a battery. So all of them gets added up. There will be more current in the circuit. Okay. And then there is a disturbance. And there is a disturbance when I'm about to teach you what is this parallel connection. If I just go back to the previous slide, Nana, in the circuit, if at all somewhere the circuit is broken, somewhere between the batteries, the wire is, the connection is lost. So what happens? The circuit
Ma'am,
will
the
be,
entire bulb stop working.
yeah, it's not only bulbs, every component in the circuit stops working. This can be understood when we can take appliance and understand the same. So this is what we have learned in our last session. We have seen the symbols of appliances and we have understood what happens when cells are connected in series. Also what happens when bulbs are connected in series. Now let us step forward and try to understand what happens when cells are connected in parallel. Whether it is better than connecting in series or not. What are the pros and cons of connecting cells in series? Do you all have a book and a pen in hand?
Yes, ma'am.
So what do you think what happens when bulbs are connected in series?
Ma'am, when bulbs are connected in series, everyone will like every of them, each and every one of them will be like working independently.
Work independently. Do you remember, Nana?
Yes, ma'am. Then the energy won't be like divided, I think so.
Excuse me. I hope the board is clear.
Ma'am, yes, it is clear.
See, when cells are connected in series to a bulb, the bulb glows much brighter because the voltage you are supplying is getting added up.
EMF get added up.
So you are having more voltage and more voltage results in more amount of current. So when more amount of current is flowing through the bulb, it will be glowing brighter. Okay. If I connect bulbs in series, instead of taking cells in series, I go and connect two more bulbs in series. Then can you tell me something about that brightness in this case?
Ma'am, the bulbs will like dim.
The way the bulbs will not
glow
go
dimly.
brighter. The bulbs will not glow much brighter because the same amount of current is being divided. The current is divided. I mean, the energy you are supplying gets divided to all the three. In the last session, I told you that if there is only certain amount of food and I need to share it with everyone, I mean, there are three people and I have food which is enough for only a single person and I need to distribute it for three people, then no one will get sufficient food and hence they will be dim, right? So same is the case here. The voltage I am supplying in the circuit gets divided here, which means the voltage across each bulb is less when compared to the one which I have applied actually. See, if at all I am applying 5 volts, the bulbs might be taking 1 volt, see 1.5 volt and 2.5 volt. So you can see the energy, whatever is getting distributed, and hence they will not work to their full capacity. That is one point we have understood. Not only the bulbs, Nana, if I consider any appliance, I mean to say, if I am connecting my fridge, my washing machine, my television, all in series, all the three in series, then each of them will be getting only a part of electrical energy and not getting the fullest potential they need to run. So they don't work to their full capacity. Have you ever noticed the bulbs go dim? And you might have heard your parents talking that the voltage is low. It's because of the low voltage, bulbs are glowing dim. Have you ever heard this sentence spoken?
Yes, ma'am. I have even seen it.
Yeah, when there is less voltage, the bulbs will not glow to their fullest capacity. It is because less voltage means less food is supplied to the appliance. And when there is less food, it will work at a less capacity. The same thing can be taken here also. So if all the three appliances are running, not only bulbs, none, it can be any appliance. If they are connected in series, none of them will be getting enough potential to run to their full capacity and hence they will be working at a low potential.
Dimly.
Yeah, that is one drawback for connection in series. And the next one, say if three appliances are connected in series and there is somewhere a problem in the circuit, you can see here the circuit is broken. Electrons will start flowing as they come here. There is no path for them to continue to move because the circuit is broken here. How will they get connected to the other bulb and make the path? It's not possible, right?
Yes, ma'am. It's not possible.
Also,
I would
the
like
second,
to ask one doubt that, like, now you told an example, like the bulb V3 near that the circuit is broken. Then the bulb before that will glow, right?
no, it will not glow. That is what I'm trying to explain. Neha, please just hold on for a minute. I think you'll get the answer from this explanation. Even this bulb will not glow. The second terminal of the bulb is not connected to other terminal of the battery. See, if the two terminals of component are connected to two terminals of a battery, it makes a circuit. But here you can see the bulb is not connected to the second terminal. It is only connected to the first terminal. So even this bulb will not glow. And as there is a broken circuit, electrons will not pass further. Even this bulb fails and this bulb also fails. So when there is a problem anywhere in the circuit, which means if one appliance stop working, all others also stop working. Yes, if one bulb blows off, all other bulbs also blows off because they are connected in series, and this is the reason. Is that understood? And also,
Yes,
it will.
ma'am.
And if I employ an electrician, if I ask an electrician to come and check the connections, he will not be able to find the problem easily. He will not be able to trace where the problem is, right? Because all the appliances are shut down. It will take time for him to Check each and every individual appliance and then find the problem. Now let us get into another connection, which is parallel. See, if all the positive terminals are connected together and the negative terminals are connected together, it makes a parallel connection. If all the positive terminals are connected together and the negative terminals are connected together separately, it makes a parallel connection. Now, if I connect a bulb here, now bulb is also parallel with the cells I am using. When I am using a single cell, the bulb will be glowing with a certain brightness to its capacity. Now, when I am connecting them in parallel, when I'm connecting two cells in parallel and a bulb is connected, what do you expect?
Ma'am, the EMF will be more, right?
No,
Ma'am,
beta.
ma'am,
Ma'am, it
Yes.
will glow more brightly.
ma'am.
Yes, Ashika?
Yeah, it will glow as usual.
Very good. It glows as usual.
Yes, it glows just as the capacity it glows when there is only one circuit.
Yes, very well said. Applauds to you, Ashika. Neha, because in series we have already seen that EMFs get added up. So you can have a guess that something opposite to that will happen in parallel. Okay. So even if I connect n number of batteries in parallel, you will have only 5 volts passing here. Did you understand?
Ma'am, why is it so?
It is because of the connection. It is being observed. It happens as so, and that is what observed. When they are connected in parallel, when cells are connected in parallel, they don't get added up. Only a single potential will be seen across the bulb, and the bulb will be glowing similar to how it glows when a single cell is connected. So the EMFs will not get added up.
Okay, ma'am.
Bulbs in parallel. Now, when I say that I'm connecting bulbs in parallel, this can also be applied to connecting appliances in parallel. So I'll be representing it with a bulb. Now I take 2 bulbs and I'm connecting a battery of volt V. Now the bulbs are connected in parallel. Now tell me what could be the brightness of both the bulbs?
Ma'am, same.
They glow to their fullest capacity because when they are
And
connected,
they glow with the fullest capacity also the same.
also the same, exactly. Because in this connection, you can see both the bulbs seem to be connected individually to the battery. The first one is individually connected to the cell. The second one is also individually connected to the cell. So both of them are individually connected to the cell, and this will supply equal energy to both of them, and hence both of them will get sufficient electrical energy to run, and they will be glowing to their fullest capacity. And my dear students, this is not only for electrical bulbs. You can apply this analogy for other electrical appliances also. So I'll be taking the same old example. If a refrigerator and a washing machine are connected in parallel to a power supply, then every appliance will work individually. The one appliance will not be interfering with the potential of the other. Every appliance will get the same potential as applied by the source or as provided by the source. If I am applying a 5 volt, So this bulb will also get 5 volt, this bulb will also get 5 volt. In general, at homes, the voltage we supply to electrical appliances is 220 volt. So when I'm connecting, I'm just writing here, Nana. When I connect washing machine and a fridge, now both of them are getting 220 volts. And depending on the resistance, they have their own current flowing through them and will work to their fullest capacity. So I'm writing here, appliances works to their fullest capacity.
Ma'am, but why? Ma'am, why do they grow to their fullest capacity or work to their fullest capacity? Ma'am, can I answer Pragya's question?
Yes.
That is because they are connected like individually, because they are not even the two bulbs or the washing machine and the fridge aren't connected to each other. They don't have any connection with each other. They only have a connection with the cell.
Exactly. Pragya,
Yes, ma'am, but I also have another question, that if they are connected to the cell, there is only one cell, and like in the series connection, in that also there is only one cell and like multiple things attached to it. Then why doesn't in parallel connection it get divided? Because the cells have connection to each other, like if the washing machine and the fridge have a connection to each other. But
Yeah.
ma'am, that with the power source is one only. Shouldn't the power be divided, because the power source is one? The power sources are not multiples.
Okay. Is that done?
Yes, ma'am.
See, I have taken initially. I told you that I'm connecting a washing machine here. Now see, I am removing it. I'm just hiding it. Now you can see that fridge is also connected to the power source. And now I connect another appliance here and hide the fridge. Now you can see this is having its own connection with the power supply, which means when appliances are connected in parallel, every appliance looks like it is separately connected to the power source. Is that understood? One appliance is not getting interfered with the other appliance. Everything seems to get connected separately and individually with the power supply. Nana, this means that this is actually potential difference.
Ma'am?
Please let me finish, please. We are just applying a potential difference. We are creating a difference in the charges for every appliance. So even an appliance connected here will have the same difference in the charges. If I connected some other here, it will also have same difference in the charges. And every component will have different resistance. Like just how in the class, everybody is not having the same capacity of understanding. You have your own capacities. The same thing can be applied to appliances also. Each appliance has a different requirement of current because of their different resistances. And though you supply the same voltage, different amount of currents will be flowing through them, which are required by those appliances, and they run smoothly. You cannot actually predict the reason why it is so, because it's a natural phenomenon. It is been observed experimentally that when appliances are connected in parallel, the voltage will not be divided. Instead, the same voltage will be seen across every component